Hey folks, new module today. This is going to be chapter 10, part 1, and I'm actually going to give you a fair amount of historical background on where modern microeconomics comes from. And this is going to go back to what was known as the diamond water paradox. And the marginalists, who we've already mentioned in this class, these are the folks who end up fixing the diamond water paradox. And the way that they fix it is by refining utility. So we're going to talk quite a bit today about the utility theory of value, which is essentially modern microeconomics answer for where prices come from. Let's go ahead and get started. Okay, economics has got to explain where prices come from. A market society gets everybody to allocate, produce, and distribute based on price cues. So if economists can't tell you where prices come from or why they are what they are, economists can't tell you very much. Adam Smith recognized early on that there were two major options for explaining prices. There was utility and labor. The utility theory of value basically said that objects were useful and brought happiness, therefore they held value. So really useful things that made you happy should be really expensive, and things that were not particularly useful should be cheap. Smith recognized that this was going to be a real problem for utility because water was free and things like diamonds were expensive. He looked at this and said, what's more useful than water? It keeps you alive. Presumably, that also makes you happy. Water should be really expensive, but of course, it wasn't. Diamonds, on the other hand, were nothing more than a trinket or a bauble. They were a shiny thing, but they were hugely expensive. So this seems like a massive counterexample for the utility theory of value, and in fact, it was so damning Smith actually junked the utility theory of value. He didn't do much with it at all. The other option at the time was the labor theory of value. And the labor theory of value said that objects were worth the amount of labor required to create all the tools and bring the actual object into being. So this was not a paradox for labor because water required practically no labor. That's why it was free. Diamonds, on the other hand, required that you had all kinds of tools, dug a mine shaft, brought it out of the ground, cut it up, polished it, etc. Diamonds were expensive because they represented a lot of embodied labor. This is why a lot of early theorists like Malthus, Ricardo, and Marx preferred the labor theory of value. Now, if you're paying attention, you probably recognize Marx's name, even if you don't recognize Malthus and Ricardo, although you should recognize Ricardo. Marx basically was a huge critic of capitalism, and he polished up the labor theory of value and got to all kinds of conclusions about how capitalism was going to cause conflict, it was going to suffer from crises, and it was essentially going to exploit workers. This was a huge problem for anyone who still wanted to advocate for markets. And it became obvious that if you were going to advocate for markets, you needed to be able to explain markets with another theory other than the labor theory of value. They needed to fix the utility theory of value. Whereas the labor theory highlighted conflict in production and crises, the utility theory of value highlighted exchange and generally lent itself to arguments about how a market was an institution that produced happiness. It allowed people to get better off through voluntary exchange. There were three independent theorists, Stanley Jevons, Carl Menger, and Leon Walras, all who managed to fix the diamond water paradox in the early, about 1870. Each one of these folks had recognized that there's a difference between what the last unit of a good gets you in terms of happiness or usefulness and what a whole set of goods gets you. Smith had been focusing on the latter. He was thinking about what water was worth to you, as in, do I get water or do I not get water, period. He was not thinking about what the last cup of water was worth to you. If you want to start talking about the last cup of water, then you're talking about the former. You are now discussing marginal utility. What amount of happiness is generated from the last unit of water that you consume? Jevons, Menger, and Vol-Ra, to varying degrees, all recognized that by separating out total utility from marginal utility, that you would actually be able to generate a theory of prices based on marginal utility, not on total utility. What we're willing to pay for an object is based on what the next unit is worth to us, not on what the entire set of those objects are worth to us. So this critical difference basically unlocked the diamond water paradox and launched what you could think of as modern microeconomics at this point. So let's revisit modern micro and our golden rule and talk about how this matches up with the marginalist's perspective. Our golden rule is marginal benefit equals marginal cost for our last unit. Well, if you think about this from the consumer's perspective, this is nothing more than saying that you want the marginal utility of your last unit to equal the marginal cost or price you paid for that unit. In other words, it's just a theme and variation on our golden rule. And a later marginalist by the name of Alfred Marshall was actually quite good at describing this process. He described a little kid who was harvesting blueberries, and that little kid would continue to harvest more and more handfuls of blueberries as long as the enjoyment of procuring and eating those blueberries was greater than the trouble or the cost of getting the next handful of blueberries. The kid was going to stop when the last unit was equal to the cost or the trouble of acquiring that unit. So in our context, MU is really just the marginal benefit, and the price you pay for the last unit is the marginal cost. So just like that little kid, consumers, if they're getting a good deal and MU is bigger than P, there's an incentive for them to keep consuming. And they're going to want to stop when the last unit has a marginal utility equal to the price, or MB equals MC is the case. Now, a hidden assumption here is that we are assuming that MU is falling, right? And this probably slipped right past you without even noticing. We were talking about the little kid finding the blueberries less and less interesting as they continued to harvest. Why? Why would we assume that? The marginalist thought that you could count on objects, goods, services, generating less happiness for you the more and more that you got of them. If you think about this, almost everything in life works this way. The more that you get of it, the less that you tend to appreciate it. So we can show this in a table in a quick little example. Suppose that you like cheesecake and you start eating it. As you start eating it, you're going to generate happiness for yourself, and we're going to show that here with total utility. And of course, total utility is rising as we eat more and more units of cheesecake. But you can see that it's rising by smaller and smaller amounts. And when we start talking about how much it's rising per unit, we've drifted over into a conversation about marginal utility. And we can see that the first unit here is generating us 20 utils of happiness. Brief side note, we're going to act like we can measure happiness, mostly just because it's easier to talk about this. If you want to see formal solutions that can avoid actually having to measure it, You'll have to get a little further into economics, but there's a peek at how you could do it in the appendix for chapter 10. Okay, so as we continue to consume cheesecake, the second unit is only going to generate 30 utils, and that's good because it actually has gone up. And they were okay with it going up at first, but what they were going to insist is that the more you got of something, eventually it's going to start producing less. And at this point right here, we are going to say that diminishing marginal returns has set in, because our third actually is going to generate less for us than our second. Okay? And every unit after this is going to generate less and less and less. And if we went far enough, we could probably even talk about negative marginal utility. But if you've got rational folks, they shouldn't be looking to make themselves unhappy. Keep in mind, micro assumes you're rational. So this marginal utility was essential because whether or not you were willing to pay the price for a piece of cheesecake was going to depend on what the next piece of cheesecake was worth to you. The only way you'd ever ask for 7 units is if it was free, because obviously it's not generating you any real benefits. So you weren't going to be willing to give up any price in order to get it if it didn't generate you anything. We can start to go ahead and graph total utility. And it's okay for total utility to increase at an increasing rate for a little bit, but we're going to essentially demand that it starts to increase at a decreasing rate, this area of the graph here, once it flips over. And if we go far enough and we actually start causing ourselves harm, then we're going to see that total utility actually declines. We'd be talking about like a unit number 8 over here, where we actually eat enough cheesecake that we make ourselves sick. Okay. So we can graph total utility, and it kind of looks like this mountain shape over here. And after this second unit, diminishing marginal return sets in. So no longer are we increasing at an increasing rate. From that point forward, the graph is still going up, but it's going up by smaller and smaller amounts as we move out. And of course, the Q here is our cheesecake, right? We're consuming more and more units to get ourselves more and more happiness. Now, total utility is not really that important for understanding prices. It is what consumers are interested in, though. They're going to want to maximize their total utility. But in order to start maximizing total utility, they actually are going to have to pay attention to marginal utility. So if we want to map out and graph marginal utility, we're just going to graph these numbers over Q. So at unit number 1, we're going to see that we have 20 utils, and at unit number 2, we're going to be at 30 utils, and then unit number 3, we're going to fall to 15 utils, and so on and so forth, right? Marginal utility is going to look like this, and by the time we get out here to unit number 7, marginal utility is 0. So this is what your marginal utility curve is going to look like. We'll revisit this in a second, but I want you to understand that these two curves are directly related to each other. Okay? Marginal utility hits 0 when total utility has maxed out. Okay? Now, let's go ahead and move to our next phase. Of course, our whole point is we've been trying to get to an understanding of marginal utility because we're trying to explain consumer behavior and essentially the demand curve, why they're willing to buy stuff, why they're not willing to buy stuff. Because if you think about it, our expression of prices is based on equilibrium. And equilibrium is nothing more than the intersection of supply and demand. So how do we get to these equilibrium prices? Half of the discussion is based on the demand curve. Consumers demand based on their marginal utilities. So for the sake of simplicity right now, let's say that utils are equal to dollars. And if in fact utils are equal to dollars, then we can kind of cheat and put price up here with marginal utility. And we could express it in utils or dollars. And if this is our marginal utility curve, it's downward sloping. And the reason it's downward sloping is because as we get more and more of our cheesecake, it's less interesting to us. So how do we decide whether or not we want to buy cheesecake? Let's impose a price. And if this price, let's say that it's $4, if cheesecake costs us $4, then we would want to start looking at each individual unit of cheesecake that we could consume. And that first one, if you'll remember, generated 20 utils for us. So you could ask, are you going to be interested in cheesecake if unit number 1 generates you 20 utils? And the answer would of course be yes. That's a great deal. It's $20 worth of happiness, but I only have to pay 4. Well, as long as MU is greater than price, you're going to buy. You are going to consume. And you're going to consume all the way up to the point where MU equals P. And on our table, MU finally fell to 4 at unit number 5. So we could talk about this as our Q star if you want. It's the amount of cheesecake that this person would buy if the price were $4. Right? Now obviously, if we start increasing the price of cheesecake and we increase the price to $10, if you look at the table from the last slide, our 4th unit of cheesecake generated 10 units of utility. So if the price was equal to 10, we would have stopped at unit number 4. So we can go ahead and show that here. With a higher price, we actually would back off and only request a smaller amount of cheesecake. Of course, price is rising, and us deciding to consume less cheesecake is essentially the law of demand. If price goes up, quantity demanded is supposed to go down. This individual marginal utility curve is an individual's demand curve. And of course, getting from the individual to the market is nothing more than summing up all of the quantity demanded from all of your individual consumers at any given price. Essentially, you walk around and say, cheesecake's $4, how many do you want? This particular consumer, when it was $4, wanted 5 units. You ask the next one, how many do they want? And you'd start building up all of the quantity that would actually be demanded at $4, all of the quantity demanded at $4. So really, utility is quite happy because they have an explanation of demand, and they have got half of the explanation for how we get to market prices. Hence, utility theory of value is on its way to building a general theory of prices that explains how we allocate, produce, and distribute within society. Okay, that'll do it for this first portion. We'll pick up with other utility issues in our next part.